Let's say I give you an unidentified compound and I want you to identify it, and I want you to tell me what the molecular weight of that compound is. How are you going to do that? And so in lab, people will turn to instruments referred to as mass spectrometers, which will allow us to accomplish this. And the theory behind it is pretty interesting. And so one of the techniques used in mass spec is something referred to as matrix-assisted laser desorption ionization, called MALDI. And what you do in MALDI is you will load your unknown compound into a matrix, which will go onto a sample holder, and we're going to pulse it with a high-intensity laser. And as the lasers interact with the molecule, the electrons will become excited, and they'll get to a point that they jump off of the molecule and it now gains a positive charge, or the molecule can take on a negative charge and a proton will jump onto it as well. And so what happens in these situations is we're forming these kinds of ions that will leave our sample and they will fly across our mass spectrometer in a vacuum chamber. And what's driving these ions is this delta V, a potential difference, otherwise known as voltage. And the potential difference will cause anything with the charge to have a force applied to it when it's in this electric field. And so what happens next is, depending on how many electrons or protons are added onto your unknown compound, just one molecule of it, that molecule will fly across the mass spectrometer and it will hit some kind of detector on the other side here. And with our readings from this detector, we're able to examine and generate plots that look like this. So we're able to determine the something referred to as the mass per charge, M/Z ratio, that you'll hear a lot, and as well as a relative abundance, which we don't really care too much about. The main thing we're interested in are these adjacent peaks here and here, and they can be any two adjacent peaks, but in this particular spectra we don't have too many. And so what we do with these two adjacent peaks is, I'll call this one A and I'll call the next one B. We're going to note how I'm going to let A is greater than B. So A would be about 15,000, B would be somewhere between, or 150,000, and B would be somewhere between 50 and 100, so 75K. But the units don't really matter. What we're going to do is set up two equations to determine what the molecular weight of this compound is, as well as the number of protons or electrons that were added or removed respectively from the molecule. And so I'm going to let A be equivalent to the molecular weight of our compound plus n protons that were added to it divided by n. And I'm going to let B be equal to the same molecular weight of our compound plus n plus 1. So it had an additional proton added to it. We don't know what n is, but we know it has an additional one because it's an adjacent peak. And we're going to divide this term by n plus 1. And so what we get from this are two equations, 1 and 2, that we can solve via substitution or elimination. It's just algebra. And we can solve for the molecular weight as well as n. And so with this molecular weight value, you now have another piece of information in your puzzle to determine the identity of your unknown compound. In addition to that, there are other kinds of mass spectroscopy techniques in which we use quadrupoles to essentially obliterate these molecules and form these radicals that will fling out and hit a detector, and we'll get all these different mass to charge ratios based on homolytic bond breakage, where a pair of electrons will break evenly, so one electron will go to each part of the fragment, and with that information, based on that unique spectra of mass to charge ratios, we can identify compounds. And so this kind of wraps up a introduction to mass spectroscopy, how people are able to use it in practice. I will go over a video, an example of how we can determine a molecular weight, for instance, from this information. And I hope you guys find it useful. Let me know if you have any questions, and thanks for watching.